Okay, guys, we are looking at Lesson 6.8, which is graphing radical functions. It is our last lesson in this chapter, which means we will be looking at chapter tests coming up. If I had to say, I think I have it tentatively scheduled for next Tuesday. Okay, so that's the, see how this week finishes out and everything, but that would be probably the soonest it would be. So, we talked a little bit about graphs yesterday. Today we are specifically talking about graphing radical functions. We're going to focus on square roots. We're going to do a little bit with cube roots. Okay? So, since chapter 2 this year, do you guys remember that chart and how to know if something is moving left or right, moving up or down, reflecting? Do you remember all those? Okay. That's kind of a variation of what this chart is. Stretch and shrink, compression, those kind of things. The idea here is the parent function. So your parent function, your main overall graph, whether it just be y equals the square root of x, or it could be y equals any root of x. Okay. So as I said, we're mostly working with square roots. We'll also talk about cube roots today, though. A reflection. If you're going to have a reflection across the x-axis, so remind me, which one's the x-axis? Horizontal, yes. So reflection across the x-axis means flipping up and down. So if we're going to have a reflection in the x-axis, that's going to be indicated by a negative out front here. Okay, a negative out front. If, and it's not listed in this chart, if it was a reflection in the y-axis, the negative would be directly on the x, which is difficult because in a square root, that sometimes you can't really do that as well. It makes numbers negative. So, do you remember if it was y equals a times something? That a represents either some kind of stretch or shrink by a factor of whatever that number is. So, stretch, pulling it up more, shrink, squishing it down more. Okay, and then the ones that we've probably done the most with, horizontal and vertical translations. Y equals the square root of x minus h plus k. Okay. Which is the horizontal aspect that's going to move it left or right, and which is the vertical aspect that's going to move it up or down. Think about what we've talked about this year. In my opinion, you should be able to figure this out. Because what do I talk about when we're moving stuff? I talk about, is it just added or subtracted at the end? Or is it added and subtracted within parentheses? We don't have parentheses here. We have a radical, but it's the same idea. So what's this h going to do here? If it was in parentheses, this one's in the square root, added or subtracted, what's that h going to do? Move it where? Left or right. Okay, so that h represents your horizontal movement. In other words, left or right. Okay, so remember when the number is in the parentheses with the x, or in this case, under the radical with the x, it tells you to move left or right. Do you remember how I always say this? Opposite is the direction of the sign, right? That's why it's the x minus h. What about that plus k? Plus k is the vertical. So that's going to tell us how far up or down to move. So vertical, and it's up and down. Okay, and that one we usually move the direction of the sign. So if it says plus a number, you move up that number. If it says minus a number, you move down that number. Whereas the other one, you move opposite what you expect. Does that sound a little familiar? You guys are giving me this look like...
Yeah, that's not...
Okay.
I remember it. Sure.
Okay, well, I'm thinking we'll get it here in a moment. Okay, so some basic graphs. I teach these graphs by XY chart to the basic, kind of like how we did parabolas. I don't know, do you guys remember your parabola chart? It was 0, 0, 1, 1, 2, 4. And we could always take a parabola and move it left or right, up or down. Once you had that new vertex, you could just go from there. Kind of the same idea here. Okay. Let's start with the basics though. Y equals square root of x. Do you know what that graph looks like? If you don't know what a graph looks like, what's a good thing to do? How about an XY chart? Okay. This is an XY chart for y equals the square root of x. What's a good value to start with for x? What?
0.
Okay, even before 1, 0. If we put in 0, what's the square root of 0?
0.
0. I'll go with 1. What's the square root of 1? 1. What about 2? What's the square root of 2? 1.414 something, something, something. It's a decimal. Do we want to have to graph a decimal? No, we want these to be easy. So skip 2. What about 3? No. 4? Why would you pick 4? Square root of 4 is 2. What would be, if you want another number, which I'm going to put one more number, what would be the next best number to pick after 4? 9. Because, you can even go back to your blue paper if you want, right? After 4 is 9, right? The next number to pick after 9, if we really wanted to go that big, 16. Square root of 9 was 3. Just realized I didn't write it down. Negatives. I didn't get any negatives in there. Should we get some negatives in there? No, because you can't take the square root of a negative when we're working with real numbers, right? So we can't take the square root of a negative. Okay, so let's graph this. 0, 0. 1, 1, so over 1, up 1. 4, 2. Over 4, up 2. And 9, 3. Over 9, up 3. It is not a line. It is what I would call half of a parabola. Okay? It is the positive half of the parabola. Okay, so how I'm going to teach from here is know that graph, or be able to create the XY values. Because what I'm going to teach is, okay, we're going to take that graph and we're going to translate it wherever we need it. Not saying you couldn't set up an XY chart for all of them, but sometimes easier said than done. So ready to try B? Y equals the square root of x minus 2. What can you identify is going on with that graph? Okay, that 2 is moving it down because the 2 is outside the radical, yes? And that means up or down. The minus is going to be down. So we're going to take our graph, we just graphed last time, and move each of those dots down 2. Couple of different ways you can do it. Could you lightly graph all of your previous dots and then move them each down 2? You could. You could graph 0, 0, 1, 1, 4, 2, and 9, 3. There's nothing wrong. I mean, easier to do on paper and pencil than it is on the computer, right? But you could graph those and just take each of those dots and move them down 2. So that means, it's not really a vertex, but I kind of call it, if I take 0, 0 and move it down 2, I'm at 0, negative 2. I can do the same thing with 1, 1, 4, 2, and 9, 3. The other option in my brain is, okay, if I know this is kind of my new vertex, how do I go from my vertex? You go over 1 up 1, over 4 up 2, and over 9 up 3. I don't know which one's easier for you guys to process through. One option is to move each dot just down 2 places. However, if you don't want to draw both sets of dots in, my other option is once I move my vertex down, from there, know how that XY chart works. That it goes over 1 up 1, over 4 up 2, over 9 up 3. It all comes down to you have to find something that works for you, right? Could you have done an XY chart? Sure. Okay, I mean, you'd still want to use that 0, 1, 4, 9, and that would come up with right values too. To me, it's a little easier to skip over the XY chart, though. I think Excel might have you do an XY chart, though. I don't remember. So, that is if you ask for their help. Did you have a question, Keaton, or are you good? You good? Okay. Okay. What's going on C? Y equals square root of x plus 1. The 1 is outside the square root, so it's up or down. Since it's a plus 1, we're going to go up 1. Okay, so if you would like, you can put the original dots on at 0, 0, 1, 1, 4, 2, and 9, 3. Then take each of those dots and move them up 1. Or move that vertex up 1, and then from there go over 1 up 1, over 4 up 2, and over 9 up 3 from your new vertex. Okay, you got it? Moving down to the next row. The next row does have a wrong heading. That should say translating horizontally. Okay. Y equals square root of x plus 2. What do you know? Left 2. That plus 2 is under the square root, so that's like being in parentheses, so it's left or right, opposite the sign. And so a plus 2 would make me think right, but instead I need to go left. Now, this is a type that would be hard to do an XY chart. Because if you put in your 0, 1, 4, 9, if you put in 0, 0 plus 2 is 2, now you have to do the square root of 2. If you put in 1, 1 plus 2 is 3, then you have to do the square root of 3. So this is a type, it's possible to do an XY chart, but you have to pick your numbers more carefully, which is why I prefer the just translating. Okay? Okay. If I start with my original dots of 0, 0, 1, 1, 4, 2, and 9, 3. I'm going to move each of these dots left 2. Or move your original dot left 2, and from there, go up over 1 up 1, over 4 up 2, and over 9 up 3. What about B? Y equals the square root of x minus 3. You guys aren't answering me because a lot of you are busy working on it. Right 3? The minus 3 is under the radical, so left or right, opposite the sign since it's left to right. So my original dots, 0, 0, 1, 1, 4, 2, whoops, 9, 3. Now if I'm moving each of those dots right 3, to me there's my new starting point. I can go over 1, up 1 from there, over 4, up 2, and then over 9, up 3, which in this case, it's just 1 off the graph, isn't it? I don't know how your other math teachers are, but I'm of the opinion if it's just 1 or 2 off the graph, can you just kind of appropriately space it off to the edge? Why not? Okay, I mean, I don't have a problem with that. Now, if it's supposed to be like 20 off the graph and then you put it right at the edge of the graph, I have a problem with that because that just, doesn't make your graph look right. But I also understand if that 9-3 had ended up being way off the graph to just drop it out and not graph it. I understand that idea too. So, okay, you got it?
Yeah.
Okay, we got the basics going. I haven't even given it a shot. I haven't even turned my page. I will now, but I mean. Okay. So, needless to say, we got a little more going on here, don't we? Okay. So let's take a moment and identify what that little bit more going on is. Y equals negative 1/2 square root of x minus 3 plus 1. What can you identify about this graph? It's going to move where? Right 3. Let's start with that idea. Do you guys agree with right 3? There's a minus 3 under the radical, so that's left or right, opposite the sign. So we are going to go right 3 when we graph it. What else can you identify for me? Plus 1 at the end is up or down, direction to sign. So up 1. So we know the graph is going to have to go right 3, up 1. What else? We've got an important couple of details there. Connor?
Is that the slope?
It's not exactly a slope. We can't really... I mean, I know you want it to be, but it doesn't really work on this one like a slope. Okay, so the negative out front, remember when there's a negative out front, if you look on the front side, that is going to be a reflection. Negative out front is a reflection across the x-axis. So it's a reflection across the x, which means this graph that is normally that right, that top half of the parabola that curves up and over is now going to have to go upside down. It's going to look like the bottom half. What's the other piece we haven't talked about? You guys are avoiding it. Well, Connor tried to talk about it, I guess. He didn't. Okay, except it's not technically a stretch. Why is it a shrink and not a stretch? Less than 1, because a number 1 and above, now we're ignoring the sign because that sign is our reflection. So a number above 1 is going to be a stretch. A number smaller than 1 is going to be a shrink. So this is going to be a shrink by a factor of 1/2. Okay, it looks kind of messy, but that's just me just trying to point out to you guys all the pieces. Because now we've got to put it all together. The right 3 up 1, those will be a piece of cake. Okay. The negative isn't too bad because that's just reflecting. The thing we've got to understand how to do is to shrink the shrink of 1/2. And when we talk about stretch and shrink, you need to realize that those affect the y values. Okay? Your x values will stay the same, but those affect your y values. I'm trying to decide. I think how I'm going to do this. Do you guys remember that original set of x, y values we had on the front? This is a square root. What was the original set of x, y values? Okay, 0, 0, 1, 1, 4, 2, 9, 3. That's just basic square root of x numbers. Okay, my recommendation of a way we can do this is that we need to take each of those y values and multiply them by 1/2. Now, if we want to go ahead and take care of the reflection at the same time, you could actually multiply them by negative 1/2. And so the idea is here, by multiplying by negative 1/2, it takes care of the shrink. It takes care of the reflection, and then all we'll have to do with those dots is do our left, right, up, and down movement. Okay, and there's other ways we could do this, but that's what I'm going to choose to do. So we're going to take all of our y values and multiply them by negative 1/2. And then basically what I'm going to do is I'm going to create a new y column. Now, our x values, are they going to change any? No, because the shrink or stretch only changes the y values. So, fill in these new numbers with me. What is 0 times negative 1/2? 0 times anything is still 0. What is 1 times negative 1/2? Negative 1/2, when you multiply by 1, it just stays what it is. So 1 times negative 1/2 is negative 1/2. What is 2 times negative 1/2? Negative 1. What is 3 times negative 1/2? Okay, negative 1.5. You could say negative 3/2, but in terms of graphing, it might be easier to think negative 1.5. So the idea of what we're going to do here, notice I didn't change the x values. We're going to take our original x values and our new y values, and we're going to graph them into one set of ordered pairs. And then after we do that, then we can do our right 3 up 1. So I'm writing that down. Okay, so we've got all written out. We just have to actually do it. X values didn't change because stretch or shrink doesn't change them. Y values changed. So I went ahead and did that shrink. Because I multiplied by the negative, that's also going to take care of the reflection. Our graph will automatically be upside down. The part that we didn't do is the right 3 up 1. So we'll do that after we'll kind of graph these dots and then take each of the dots right 3 up 1. What looks weird?
Is that plus negative 1/2?
Where it says shrink 1/2?
No, like you have like the little chart that we made. It says 0 something negative 1.
Multiplication dot.
Okay, sorry.
How's that?
I just can't.
That's all right. Well, and who knows what glare there is, or you know. I could tell you guys couldn't figure something out back there. So, okay, so let's graph these dots. 0, 0 became 0, 0. So we still have a dot at 0, 0 for the moment. 1, 1 became what? 1 comma negative 1/2. So how do we graph 1 negative 1/2? Right 1, down 1/2. 4, 2 became 4 negative 1. So right 4, down 1. 9, 3 became 9 negative 1.5. So right 9, down 1.5. The down is the reflection, And then notice my y values are half of what they used to be. Am I done, or are those my final dots? No, because what have I not done? Take those dots and move them. Right 3, up 1. So if I take each of these dots, right 3, up 1. Take this next dot. Right 3, up 1. Next dot. Right 3, up 1. Next dot. And one of my dots ended up right there at the bottom of my original XY chart. Questions? Are we okay with what I've done? Now, and I'm not going to argue this is the only way to do this. Different people would do different things, okay? I'm just trying to get you guys to think about the different translations, the different things happening to the graph. Okay, you ready to try B? So start looking at B. Y equals 3 square root of x plus 2 minus 4. Okay. Plus 2 means we're going to go left 2. Let me rephrase that. Plus 2 in the radical means we're going to go left 2. Because it's left to right, opposite the sign. What do you guys say about minus 4?
Down 4.
Down 4. If it's not in the radical, not with the x, it's up or down, the direction of the sign. Did you guys say the 3 or did you avoid the 3? What is that 3 doing? It's a stretch because it's a number bigger than 1. So it's a stretch by a factor of 3. Okay. What did I do last time? I started by making XY chart. So I'm going to start the same way this time. What's our original XY chart before we change anything or do anything?
0, 1, 1, 4, 2, 9, 3.
Okay. 0, 0, 1, 1, 4, 2, 9, 3 is what you guys said. Now, what does that stretch of 3 affect? Stretch is only going to affect what? The y's. So we're only going to take the y's and multiply them each by 3. So, what do I get when I multiply y by 3? What is 0 times 3? 0. 1 times 3? 3. 2 times 3? 6. 3 times 3? 9. So where are my new ordered pairs? You're going to use your original x's and your new y's. And then after you graph these, you're going to take those dots and move them left 2, down 4. Okay, you ready? So, my first set of dots, still 0, 0. When I stretch it, it's now, instead of 1, 1, 1, 3. Instead of 4, 2, 4, 6. Instead of 9, 3, 9, 9. Do you see how it stretched that graph up? How it doesn't hug nearly as close to that x-axis, it's way up there now. Take each and every one of those dots and do what? Left 2, down 4. 1, 2. 1, 2. And pay attention, I'm using 2 different colored pins, although they're kind of blurring together on this, but know which dots are which. Left 2, down 4, left 2. Oh, one very important thing I have not mentioned. Notice, am I putting arrows on both ends of this graph? No. I am only putting arrows on the right end that goes off to infinity. That other end starts at 0, 0. Can it start anywhere to the left of 0, 0? No, because that's where the x values are negative. So do not put arrows on both ends. It's a dot on this end, an arrow on the other end. Okay. You got the idea on square roots? Now, I will tell you, example 4, I have changed the examples because, first of all, what's different about example 4? They're cube roots. Do you know anything about what a cube root looks like? No. So I felt like we needed some basics as opposed to jumping into a cube root with all the other stuff on it. So I'm just giving you a couple of basics. So the 2 we're going to try for cube roots. First of all, we've got to know what the original cube root function looks like, in my opinion. So y equals cube root of x is going to be our first one. And then once we know what the cube root of function looks like, we can do the basic y equals cube root of x minus 5. Now, like earlier, if you don't know what a graph looks like, best idea is to make an XY chart. Okay. Last time for my square root chart, we ended up using 0, 1, 4, and 9. Do we want those same numbers? No. Or not the exact same numbers. What's always a good number to use? 0. What else is usually good? 1. Can we do the cube root of 1? Yeah, you can do any root of 1. It's always 1. Okay, so 0, 1. Do you want 2? Do we know the cube root of 2? Do you know the cube root of 3? Cube root of 4? What's the first cube root you know after 1? 8. Cube roots, not square roots. Okay, the cube root of 8 is 2. Now, we're not going to go to the next one because the next one you'd have to go to is the cube root of 27 is 3. What else do I need to include, though? No?
Negative.
Can we do the cube root of negatives?
Yes.
Cube root of negatives. Can we do the square root of negatives? No. Can we do the cube root of negatives? Yes. So I love the 0, the 1, and the 8. What are a couple of good negatives to use? Negative 1 and negative 8. I don't care what order your XY chart is in. I like mine to be in order, which is why I hadn't written them down yet. I don't know if you guys caught on to that or not. Okay. What is the cube root of negative 8? Negative 2. The cube root of 8 is 2. The cube root of a negative is a negative. What's the cube root of negative 1? Negative 1. Cube root of 0. 0. Cube root of 1. 1. Cube root of 8. 2. Okay, let's graph them. This will be our basic design here. negative 8, negative 2. So left 8, down 2. Left 1, down 1. 0, 0. Right 1, up 1. Right 8, up 2. You know how to connect these. Looks something like this. Have we seen a variation of this graph before? Yeah. This is, do you guys remember the graph y equals x to the third? Y equals x to the third is the upright version of this, where it starts at the left, goes up to the right. Since this is the cube root of x, it's reflected and ends up sideways. Okay. So how do you feel about b now? Is b looking okay? Remember, my b is y equals the cube root of x minus 5. What are we going to do on b? Take each of those dots and go down 5. And that's doable, yes? So if you want to put your original dots in, you've got the negative 8, negative 2. You've got the 3 that go right there through the center. And you've got positive 8, positive 2. Might be easier in something like this. You move each of those dots down individually. Or move the center dot and know where the rest of the dots are in relation. So if I move my center dot down 5, there's my new centering if you want. From there I can go left 1, down 1. I can go left 8, down 2 from that point. Right 1, up 1. Right 8, up 2. Or as we said, it's down 5 from all the other dots. Notice arrows on both ends of this one. This does extend indefinitely. We can indefinitely use positive values. We can indefinitely use negative values. Okay, we're going to look at least example 5. We'll try example 5a real quick, see what happens. They're so close here. We may have to talk about more tomorrow. How can you rewrite y equals square root of 9x plus 18 using transformations and describe the graph? Right now, if I asked you to graph square root of 9x plus 18, you don't really know anything, do you? Okay. 9 and 18. What do 9 and 18 have in common? Do they have a GCF of 9? Okay, so let me do some work here. First of all, I can rewrite this as y equals the square root, and under that radical, I can factor out the 9. So if I factor out the 9, what remains in the parentheses? X plus 2. Now, what's even better here, that 9, not by coincidence, it's by design, is a perfect square. What is the square root of 9? 3. And because it's a factor, it's not added or subtracted to anything, it's multiplied by the others, we can bring that outside. So this is now y equals 3 times the square root of x plus 2. When they asked us to rewrite it using transformations, that's what I've done at this point. Because now, based on what we've done today, I would like to think you would have an idea of how to graph this. Because what we would have to do, we'd have to start with the square root of x graph, right? And what would you do to that square root of x graph? You would have to stretch it by 3 and move it left 2. That's doable now since you rewrote it, yes? Okay, so I'm going to put that in words. Describe the graph. Well, first of all, it's going to be the graph of y equals the square root of x. Because you have to tell me what graph are we starting with here. And it's going to be stretched by a factor of 3 and translated left 2 units. You know, if you see something like this on Math Excel, you'll be picking out multiple choice. However, that's not how it'll be on my test, right? Okay. So notice I used some good vocabulary. I used the word stretched, translated. Okay. I didn't just say moved, left 2. It's translated officially. Are you seeing how those work? Obviously, I'm going to run out of time for this last one, but there's a GCF of 8, and since this is a cube root, 8 just happens to be a perfect cube. Okay? So that would be this one. So I could factor 8 times x plus 4, and then minus 2. I can take the cube root of 8, so it's 2 times the cube root of x plus 4 minus 2. There is my rewrite. And for my description, I'm going to start by identifying the graph. Hold on. Finish the homework for tomorrow, guys, or come with just a few questions. This is the graph of y equals the cube root of x. And we have a stretch of 2 out here. The plus 4 under the radical moves left 4. And the minus 2 outside is going to go down 2. So I'm going to put that all in words. So this graph is stretched by a factor of 2 and translated down 2 units and left 4 units.
I had a wisdom tooth consultation. I did. Was it the same thing that we've been doing? It was like listening.
Okay.
Was it over?
Finish lesson 6-8.